Okay guys, so today we're moving on into section 5.5. This is going to have to do with converting exponential functions into logs and converting logs into exponentials. A lot of people are, pretty comfortable with logarithms. It's not so bad, but I really want you to understand what it means. A lot of times people will see this function and they think there's something completely different, when they're really not. They mean exactly the same thing. Log base a of y equals x. Another way to write it is a to the x equals y. They mean exactly the same thing. Let me just show you that by showing it to you on the calculator. Let's say that we have log base 2 of 3 equals x. This isn't a great example of how to do that. I would have to be able to type this into the calculator. I was going to show you a list of points. But what I could do is I could if you recognize that any base that I chose, if I chose a base of 3, so like if I did log base 3 of 9, that would be 2. And here you can see that 3 to the second is also going to equal 9. So that's the reason they are equivalent. So what would be equivalent to this then? If I had m equals log base b of n, what would that be equivalent to? Yeah, b to the m is equal to n. So these would be an equivalent function. This would be the exact same thing as that. Now remember to find inverses. To find inverses, y becomes x, x becomes y. That's how we always find an inverse. In fact, just to remind you of this, if I had the function say y equals 2 to the x, if I'm graphing that function, that means that 2 to the 0 power is 1, 2 to the first is 2, and I know it's never going to go below the x-axis. So that's the way that y equals 2 to the x looks. If I wanted the inverse of this, then my y becomes x, and my x becomes y. I can't type that into the calculator, and it's kind of hard to work with this way. I could make a table of values, though. So I would plug in for y. Maybe plug in 0 and 1. So 2 to the 0 would be 1. 2 to the first would be 2. So now my key points are going to be 1, 0, and 2, 1. And so this is the way this function looks. So these two are inverses because y became x, x became y. Now another way to write this would have been log, find the base, 2 of x equals y. So this is the inverse of that. And see how it is a reflection over the line, y equals x? It's just a reflection. Y becomes x, x becomes y. All right, so now how would we do that with a more abstract function? If we have log base a of y equals x, how do I write the inverse in log form? What would it be? Just change the... Right, log base a of x equals y. That would be the inverse. Okay? Now I want to write the inverse in exponential form. So how do I write this inverse in exponential form? A to the y equals x. Okay? So just understanding the difference between equivalency and inverses is important. All right, so this problem we're trying to evaluate. We have log base 3 of 1 over 81. I could do this on my calculator. Watch how I can do it. I can go under math and I can arrow up and get to log base. And I can do log base 3 of 1 over 81. And my calculator tells me it's negative 4. But why is it negative 4? Well, think about what it means. I just say this equals x. How would I swirl this around and turn it into an exponential? 3 to the what? X equals 1 over 81. So if I do 3 to the second, that's 9. 3 to the third is 27. 3 to the fourth is 81. And how do I make it go to the bottom? Make it a negative, right? So this answer then is negative 4. And we can see that we can do it on our calculator or we can do it by hand. Now, some of you may have older calculators that don't have this math log base. If you have an older calculator, you have to use the change of base formula, which says that to evaluate this, I'd have to do log 1 over 81 divided by log 3. That's the change of base formula. So I would do log 1 over 81 divided by log 3. And it'll still give me the same answer of negative 4. This change of base formula changes it to a base of 10, but it can change it to a base of anything. Base of 2, base of 3, base of 1,000,000. It would work for anything. Okay? All right, so what about this? Let's not rely on our calculator and think it through. Anybody know what the answer would be? Can you explain why, Faith?
It's because if you make it equal to x, then 6 to the x equals 1.
Exactly. Okay? So don't rely on your calculator for these easy problems. All right, this one, same kind of thing. We're going to say equals x. So it's 125 to the x equals 5. Well, 125 is 5 times 5 times 5. So what would I have to do to this to make it equal 5? Take the what? I'd have to take the cube root of it, actually. So how do I write to the cube root? 1/3, right? So this would be x equals 1/3. And if we don't understand that, we could always do this on our calculator if we had to. I just don't like to see you grab your calculator too early when it's something that you can figure out without. Okay, so 1/3. All right. How would we solve an equation like this? Just swirl it around. What would it be equivalent to? 3 to the negative 2 equals x. So what is x going to be? 1/9. Good. It's a little bit more difficult. We have log base 10 of 0.01 equals x. So I have to rewrite this as 10 to the x equals 0.01. Instead of grabbing our calculator, let's try to think this through. What would be another name for 0.01 as a fraction? 1 over 100, right? If you didn't know that, you could use your calculator and do 0.01 and math bracket. 1 over 100. Now, how would I get 100 then? What do I have to do to 10 to get 100? Square it, and then to make it go to the bottom, what would it be? Negative 2. If I needed to use my calculator, I could do my log, and I don't even have to tell it the base because it's already base 10, and it'll tell me it's negative 2. All right. When we have double logs, we have to make sure that we condense this first. Condense it first. So this is going to go down to log base 5, and then if it's addition, what's that going to turn into? Multiplication. So multiplication would be x squared, minus 4x. Because I multiply my x times my x minus 4, x times x and x times 4. And then what's another name for this? See, I should just evaluate this. What is log base 3 of 3? 1. So just figure it out. So now I have a log in this formula, log base a of b equals c, basically. Log base a of b equals c. So I just do this. Oh my gosh, I keep writing 3 instead of c. So it's a to the c equals b. So this is going to be 5 to the first equals that. How do I solve a problem like that? It's a quadratic, so I need to get it set equal to 0. What are numbers that multiply to be 5 and subtract to be 4? Negative 5, positive 1. Okay, and so then what are our solutions? Does anybody know, though, that why negative 1 is not actually an answer? Any ideas? Let me show you a graph of this. If I'm graphing this function right here, I've got log, oops, I need to go to my log base. I've got log base 5 of x squared minus 4x. and I want to know where is that equal to 1. If I graph it, here's the way it looks. Here's this function graphed. Okay. Actually, I need to go back to my original. Hold on. If I go back and type in my original, I'm going to go to math, and I have log base 5 of x plus log base 5 of x minus 4. Okay, so that's my original function. And here's my graph of my original. Can you see how there's only one solution? There are not two solutions. So what's my only solution going to be? What's that point right there? X equals 5. I could find it by doing a second calculate, point of intersection. I can get over there close to it, enter, enter, enter. So I could even do it this way. I can find out that my solution then is going to just be x equals 5. So back again, why is it that in this original function, x is not allowed to be -1? It would mean 5 to some power has to equal -1. Would it ever be that? See, if I do 5 to any power, I always get a positive number. I'm never going to get a negative number. Even if I do 5 to the -3, it's still a positive. I can never get -1. So that's the reason why we don't use that answer of -1 and only use 5. Okay, solving equations now. What would I want to do first here? Divide by 3. So I have 5 to the x minus 1 equals 86/3. This is the whole reason we have logarithms, is to be able to solve a problem like this. How would I solve a problem like this? How do I rewrite it? Log base 5 of 86/3 has to equal what? And so now to solve for x, we're going to have to add 1. And so that's going to be our solution. And I just like to get the solution in exact form. That's the exact answer. If I wanted a decimal approximation, I could always do my math, my log base, and I could do log base 5 of 86/3 plus 1. And this would be the decimal approximation. But it's better to just get the exact answer. What about on a problem like this? Trying to figure out what x is. What can we do? I know. What's our base? 2. So we're just going to swirl it around. So what's it going to be? 2 to the second equals radical x minus 4. So I get 4 equals radical x minus 4. What would I do to both sides now? Square both sides. So 16 equals x minus 4, and so x equals 20. And I should just check, am I allowed to use 20? Well, 20 minus 4 is 16. Square root of 16 is 4. 2 to the second is 4. That works out. Last one, this is a typo. This should be saying our y equals 3 to the x and y equals log base 3 of x. Are they inverses? What do you think? Are these two things inverses of each other? How would I rewrite this one? 3 to the what? Equals x. So this is equivalent. So would that be the inverse then? Did x turn into y and y turn into x? Yeah, it did. X turned into y, y turned into x. So yes, these two are inverses because x and y switched. Okay? All right, any questions? Okay, you guys have your assignment up there, page 357, 5 through 39 on.